solve for y as a function of x. This is asking me to solve the differential equation. I was given the derivative. If you need to rewrite this as dy dx, you may do so, but the first step is always to separate variables, no matter what. So let's separate our variables accurately. I'm going to have to divide by root y. Remember, the dy cannot be in the numerator. And then, in the denominator. And the dx also has to be in the numerator. So we'll have to say x squared dx. I just can't have a dx or a dy in the denominator, right? So we're going to integrate both of those. This is the same as y to the negative 1/2 if you've forgotten some of your power rule stuff. If you need to rewrite that, you can. Remember, I'm only going to do 1 plus c. So I'm going to add 1. I get 1/2, multiply by the reciprocal. And then you have 1/3 x cubed. I'm going to go ahead and put the plus c on the x side because I find that easier. Probably the easiest thing to do at this point would be to divide by 2. So I'll divide by 2. I'll go ahead and write that as root y. I can do 1/6. Dividing by 2 is multiplying by 1/2. I don't have to multiply the c by 1/2 because it's still just a constant. And now I need to square. So if I was solving this, now that c is going to be trapped inside the square. Remember, I'm not just going to square this piece, because if that was a number and I wanted to square both sides, the c would be trapped. I just want to make sure that you can see that. So I'm going to solve this in 2 different pieces. I'm actually going to go back, and I'm going to use this step right here, and I'm going to say, what if I solve for c at that step? So I'm going to draw an arrow so you can tell what's happening. Because I like to solve for c before the c actually gets trapped into that. I find it easier. So I'm going to do 2y to the 1/2 equals, I'm just going to rewrite it where you can see what's going on. And then I'm going to plug in my points. So for x, I'm going to plug in a 3, and for y, I'm going to plug in a 4. So 2 root 4 equals 1/3. And then 3 cubed, which is 27. So this is going to end up being 4. 27 over 3 is 9. So it looks like c is equal to -5. You have to plug in this c at that step. So I'm going to do 2y to the 1/2 equals 1/3 x cubed minus 5. Now my first step in solving for y is to divide everything by 2. So y to the 1/2 is equal to 1/6 x cubed minus 5 over 2. You have to multiply both pieces by 1/2 or divide both terms by 1/2. Now I'm going to square both sides, and I get 1/6 x cubed minus 5/2, and all of that would be squared. Now, technically, there's a couple of different ways you could manipulate that. You could technically factor out a 1/6, but the 1/6 is squared. So if you want to think about it as 1/6 x cubed, what would that be? Minus 15, I believe. If all of that is squared, you could think about it as 1/36 x cubed minus 15 squared. That's another way to write it, but this is perfectly acceptable. Now, what if I solve for c at a different step, though? What if I got all the way to here and then decided to solve for c? What would that look like? Well, let's see what that looks like. If you plugged in a 4 for y, here, let me rewrite. Oops, sorry about that. Jumped around a little bit. Let me rewrite the y equals 1/6 x cubed plus c all squared. There we go. Now plug in a 4 for y. Plug in a 3 for x, which again, that's your 27 because 3 cubed. And then plus c all squared. So I'm trying to get rid of the squared, which means I have to square root both sides. Square root of 4 is just 2, not plus or minus 2. All right, so now I have 27/6. If you want to reduce that, you could divide both by 3, so that gives you your 9/2. Oh, jumped on me. So now I want to subtract this 9 halves here. Subtract 9 halves. So C, if you wanted to do a little, remember that would be the same as just 4 over 2. So C would be negative 5 halves. Well, that's not the same thing that we just got. We got C is equal to negative 5 here. And here we got C is equal to negative 5 halves. But remember, it matters the step in which I solve. So if I now go back to the step in which I solved at, which is right there, and I said, okay, I got to plug in that negative 5 halves, I would get y equals 1/6 x cubed minus 5 halves all squared. Oh, look, those are the exact same. So that's a good example of you getting different C values depending on the step in which you solve. But ultimately, your final answer should always be the same whenever you solve for y.